Hello, friends. My name is Ryan Schul. Welcome to my channel if you're new, and if you're coming back, then welcome back. So, this channel is all about data science, machine learning, deep learning, things like this. Today's lesson, I'm going to show you a comparison of a standard LLM. You probably know by now, large language model, right? If you don't know, but then now you do. So you've probably heard of LLMs in the past. We're going to explore an LLM. We're going to take a look at um, text retrieval technique plus LLM. Okay, so it's like an enhanced LLM. We're going to look at an example of a dense retrieval and a fourth example of an embedding-based search of text. So I'm going to throw a couple PDFs. I think I have 3 PDFs in one Word file into a folder. I'm going to scan through these documents, extract the text, fetch that, and do some analysis on the text. And I'm going to show you how each of these models performs on that text and how it can understand the text, the embeddings within the document, converting the text to numerical representations of the text so the computer can interpret that more accurately and things like that. So it's very cool. Hopefully you can stick with this until the end. I like this kind of stuff. And I did the analysis yesterday, and let me show you my findings today. So basically, the first thing we're going to look at is a standard LLM. This is a large language model. You see this all the time in Chat GPT. BERT is another example of this. These are typically pre-trained models that look at a huge corpus of text. This can be billions and billions of columns. A column is like a feature, and it can look at billions of columns of features, or columns and features. It's basically the same thing, and then train the model on this. Then if you go ahead and ask a question to the model, it's going to respond back and say, oh, yes, I know how to do this, or I know how to do this, or let me answer your question. Let me help you with that kind of thing. Okay, that's an LLM. Text retrieval plus LLM is a slightly enhanced LLM where the system first retrieves relevant documents or chunks of text from a collection called a body or corpus of text, and it uses techniques like TF-IDF. I have videos on this. This is text frequency, inverse document frequency, BM25, or other embeddings in text. It uses this to interpret and to understand the text. Then you can ask the model questions because it has read the text. It's almost like a person reading a book. Okay, I have an 8-year-old son. I ask him to read books. He's usually pretty good about it. Sometimes he resists and he pushes back and says, no, I want to play with my Legos. But usually he'll read his book. And then I can ask him questions about the book to see if he actually read it or if he was actually playing with the Legos when he was supposed to be reading the book. So LLM is kind of like that, right? It reads the book. It doesn't play with Legos, hopefully. It reads the book. And then you can ask it questions, just like I can ask my 8-year-old son questions. And if he can answer the questions correctly, I know that he read the book, okay? Another technique is called Dense Retrieval model. This is more to generate vector embeddings for both the query and the document. So you'll see how this works in just a moment. I'm going to query all the documents in the folder. Well, I'm going to query the documents, but maybe a better term is I'm going to fetch all the documents in the folder, convert that to text, clean up the text a little bit, and then give a query to the model. A query is a question. Sometimes people say, do you have a query for me? It's a little bit annoying to hear them say things like that, but basically it means a question. A query is a question, right? And then we can create scoring based on how accurately the question or the query is represented by the document. So you'll see how that works in just a moment. It's very cool. It's very fresh. I'm going to show you that. And there's one more technique I want to introduce you to. This is called embedding-based search. This is where we, similar to what I just described with the dense retrieval model, the dense vector embeddings in the query are matched with in the text. I'm sorry, I keep misspeaking here. In the body of text is matched with the query, which is a question that you're asking to the text. And again, we're going to get a quantifiable measure of how accurately the question is represented in the text or captured in the text, right? You will get a ranking from 0 to 100 and saying, this text is very useful for answering this question, or maybe it's not, right? But the whole concept here is to use these 4 different models and see the different approaches, compare and contrast, and see what the results of each one is, and see which one is better at handling the task, because it really depends on what you're trying to do. All these models are great for certain things. They might be better for some things, and they might not be as good as some other models for some things too. So really the best practice is to test a bunch of different models, like I'm going to show you how to do, see which one responds best to the test, and then pick that model to work with, or if you're doing a deployment for your team or for some stakeholder, to deploy that model. But the only way to know which one is going to perform the best is to train all these models and then test them and see what kind of results you get. Okay. So the first thing I'm going to do is refresh the cell, and all my files are kept in this folder right here. It's called Desktop Risk. I did another video earlier today about risk management for banks. So I'm just going to use the same types of files over here and just recycle it, just a little bit easier for me. Different takeaway and different purpose here, but the other video was about risk management, right? Or kind of like scanning through different documents and getting the text from the documents, and then seeing which documents have keywords. We're going to do the same thing here, but this is going to be a little bit more like text analysis on steroids, because we're going to do a whole bunch of things that I didn't do in the other video. And again, like, you really have to understand what the takeaway is, or what the ask is, and then deliver the right tool, or use the right tool to deliver to your stakeholders what you need to do. So this is the first example here. I just want to show you how Python is able to go into a PDF file. This one's called Future of Bank Risk Management.pdf. This is a PDF file, and that's the file right there. And it just basically gets the text and prints out the first 500 characters. That's all it's doing. Nothing very intelligent, nothing very smart right there. We're just going to, I'm just showing you how how Python can read from a text file, or read from a PDF file, which is really basically just a text file. It's just a very enhanced text file. If you open the PDF and save it as a text file, you'll have all the text exactly the same. The view will be a little bit different, but everything, all the meaning and the purpose of the file is the same. So here's the first example I want to show you. This is just a standard LLM. We're importing a couple different libraries, and I'm doing a cosine similarity test here, so I can understand how similar this question is. This is the question I told you about before, or the query. Sometimes people call it a query. I think it's basically just a question. Should a bank be able to generate an accurate and reliable risk data to meet normal stress crisis reporting accuracy requirements? Okay, so it's kind of a mouthful. I worked in the banking business for a number of years, so that's why I picked this example. But look, the point is, you can scan through any kind of document you want, any kind of PDF. It can be a text file. I have a Word document in the folder too. It can be any data source that you want. These four models go ahead and scan through all the text in the files that you place in the folder. And it can be 4 files like I'm using here. It can be 400. It can be 400,000 or 4 million or 10 million. It doesn't matter, right? But you want to get the model to go ahead and fetch all the data from all these files and combine that into one large corpus of text. This is a body of text. So you can ask it a question, and it's going to go ahead and answer your question. So the first question I have is about risk metrics and stress reporting and banking crisis, something or other. Whatever the question is, you can propose the question. Let me go ahead and refresh this, and we'll get the results in just a minute. And by the way, a lot of pre-trained models have been trained on a certain type of text document or certain scenario. So some pre-trained models are better at analyzing some type of data. They're not all created the same, okay? You really have to scan through these models. And if I go to BERT or Hugging Face, I think that's what it's called, you can search around for the model that's most appropriate for you. So you want to get a pre-trained model, but not just any pre-trained model. BERTs. Not just any model. You have to kind of like search around and see which one is going to suit your needs and be the best for your specific scenario over here. So search documentation. This is Hugging Face community. It's pretty big. I thought, let me go back for a second. I thought they had like some different Google BERT models. Oh yeah, I think this is what I was looking for. Models, maybe. Let's see if it can do it. I'm trying to do is a simple click here, but maybe it can't. Maybe it can't. I can't do the click. Okay. Well, it's not gonna get an A plus for speed here. Maybe a B, maybe a C. Okay, yeah, this is what I was looking for basically. So you're up to 67,000 models now. So that's a few. Okay, I'm not kidding you. That's quite a few. I thought when I looked at this last time, it was way less than that. So they're spitting out new models every single day, I guess. So you have to kind of look for the model you want. And if this is banking risk, I don't even know if they have this, but they probably do. Oh, zero. They actually have zero. They have banking, 107 models relevant to banking. So one of these would be more helpful than just picking just a random model on, I don't know, like history or something. So they have 11 models in history. But the point is you would come here, search for the model you want, and then use that model right here, okay, in this spot. This is a model that you would pick, okay? So I'm using a very large model here. This is a Google-based model, and you would just put that into your pipeline. So this is a summarizer. You would copy and paste that model. I looked at history, I looked at banking, but these are very different things, right? So just keep an open mind about this stuff when you're just getting into it. If you're trying to answer banking related questions or risk related questions, you want that type of model that's been pre-trained on that body of text. You wouldn't want a model about history or, I don't know, dinosaurs or famous celebrities or whatever. Like the model has to be pre-trained on the topic that you are interested in testing on. Then you're going to have a model that's more relevant and going to produce more accurate answers. It's like a subject matter expert, right? If you talk to an SME that knows everything about mechanical engineering, you ask them mechanical engineering questions, that person, that guy or girl is going to be able to answer your questions. If your question is about architecture, you need to find an SME that knows architecture. If it's about computer science or data science or history, right? You want somebody that knows the topic. So it's the same thing with these pre-trained models. Just like a person is pre-trained in some topic or subject, whatever it is, whatever they go to school for, the models have been pre-trained. You have to pick the model that's most relevant to your needs. And then when you train it and test it, you'll get decent results. If you pick just a random model over here, you can't expect fantastic results because the model simply won't know what to do, right? They're pre-trained on some topic or some subject, and they collectively learn that topic and that subject, right? That's how the model is trained on. All the transformers inside of that model are very specialized in understanding the nuances of that topic, right? Then you're going to have good success when you copy and paste that model name over here, you put the name right here, and then you run the job and you're going to get great results. If you pick a random model, then you're just going to get random results, right? It's not going to be very useful. It's not going to help you or anybody on your team. It's not going to help any of your stakeholders or anybody whatsoever. Okay, so I think we're getting close to this thing being done. I still see the hourglass in the upper left-hand corner here, so this is still running. That's fine. Again, you just go to this website, Hugging Face Models, and pick the one that's more relevant to whatever task you're doing, okay? And this thing should be finishing up pretty soon, I hope. It's 4 files in the folder, and I see 4 CPUs being run here, so I think we're almost at the end. Where's this thing over here? Yeah, 9-4, okay. And by the way, if you have a long-running process like this, you would kick it off overnight and have some type of job that triggers maybe at midnight, maybe 11 p.m., maybe 1 a.m., it doesn't matter. But if you have a job that's going to run for hours and hours, you don't want to kick that off at 9 o'clock when you get into the office, right? You want to set that up to run overnight. Then you come into the office at 9 or whatever. If you're an early bird, maybe 8, maybe even earlier than that. But everything is ready for you, ready to go when you get at your desk. You don't want to run these models when you get to the office. You want everything to be done when you get to the office, right? So something like this, it's just training, testing, and spitting out results, something like this should be run overnight, not in real time, and probably not when you're doing a demo like I'm doing right now. Okay, so I'm just showing you what not to do. This is what you do not want to do. Okay, but I think we got it. Okay, so we're in good shape. So here are the models. I'm actually only looking at the PDFs at this point, so skipping over that Word document, but you can easily set that to capture Word documents too. It doesn't matter, right? This is just an example. It's just showcasing what this LLM can do. So the retrieval score is 47.34%. Again, that's based on two things: the body of text in that file, in that PDF, and how closely this question matches what that file contains. Okay, and how do we get that? From a concept called cosine similarity. So you can go ahead and Google it. Basically, we're looking at the similarities using a very not robust, very I would call it elegant, very elegant mathematical operation where we're looking at the cosine, or the angle of closeness between what's contained in the text and the question that you're asking. So those two things are matched together, and then you'll get the quantitative score down here. So this question matches this body of text, right? The future of bank risk management, 47.34% accurate. And then it's printing out the first 1,000 characters just so you can see why it's coming up with that score. So 47.34% is just not some random thing that the computer comes up with. It looks at the similarity of the body of text and the question, and it proves it to you. Okay, by 2025, risk function banks will likely need to be fundamentally different than they are today. So that kind of answers the question, right? Should a bank be able to generate reliable risk data and report accurately, right? So where the document talks about that, banks will need to be fundamentally different. As hard as it may be to believe, the next 10 years in risk management may be subject to more transformation than the last decade. Okay, so that's interesting. Kind of answers the question: are banks able to measure risk accurately right now? Probably not. Some people would say yes, some would say no. But this document is saying it's kind of good, but it needs to get better. So is this question being answered in this document? The FDIC Community Banking Study was published in December 2012 and updated in 2020. Does that actually answer the question? Not really. That's why I got a lower score. And this comes back with the following people are members of the standards implementation group. That totally doesn't answer the question at all, right? So it got a much lower score of 12%. So let's look at the next example here. I'll run this. I think this one is a little bit faster than the last one. So this is the next sort of concept here, or the next technique. We just looked at standard LLM. This is an LLM plus retrieval. Okay, so we have an enhanced LLM, kind of like probably a little bit more efficient and a little bit more accurate in its ability to do the matching using this concept that we saw before, cosine similarity. How closely does the body of text match the question that's being asked to the model, and a sentence transformer. So this is how all these models run. All these LLM models use transformers to take everything and transform the text into a format that the model can comprehend and interpret, and then learn from, so it can go ahead and spit out good answers and help you answer your questions, right? So help you with your homework, help you with your research, just help you to get answers to whatever type of question you need help with, right? So what is financial risk? I actually want that question to be a little bit different. I'm not going to rerun that. I think that's fine. And the first document, this one came back, the future of bank risk management, and it just says risk management. So 47.74% accurate. I actually wanted to ask you a different question. Let me cancel this thing. Let me kill it right now and just restart the process. Okay, so let me kick it off again, because the question I really want to ask was, should a bank be able to generate accurate and reliable risk data to meet normal stress crisis reporting accuracy requirements? Okay, so I was talking about risk management for another video. I think that's how that got in there. Copied and pasted the wrong thing. But that's fine. But you can see, like, you have to ask a relevant question too. If it's not contained in those documents, then you're not going to get an answer to your question. And that's why these LLMs are so powerful, right? So you can imagine I'm just scanning through 3 PDFs right here, training the model on these 3, and then asking it a question. But when you work with things like Chat GPT or BERT or whatever, Hugging Face is one, there's several out now, I forget all the names. I use Chat GPT more than the others, so I know that one pretty well. But when you train these models on these bodies of text and you have billions and billions and billions of PDFs and web scraping processes will go out and scrape countless amounts of information off of all kinds of websites. It goes all over Wikipedia, it goes all over Amazon.com, all over Microsoft, and whatever, YouTube. I'm sure it's scanning through all kinds of YouTube videos, Facebook, and all these things, and collecting all this information. It's harvesting information and sucking up all this information like a giant digital vacuum cleaner. You're going to get lots and lots of information out there that the model can sort through and analyze, and then you can ask it these questions. That's what works. So I just gave it 3. I gave the model 3 sources of information right here, right? Just these 3 PDFs: the risk review, BCBS 239, and the future of risk management. So it can make some accurate analysis and some decent predictions. But can you imagine how powerful this thing would be if you scan over 1 billion PDFs? It would be much more robust and much more powerful and much more interactive. In this case, if I had 1 billion PDFs, I don't even think it would fit on my laptop, but I could do that type of analysis. It would take quite a while. But that's how these things work, right? So ChatGPT has already scanned through billions of PDFs. That's great. I don't have billions of PDFs, so I can't do that, but I have 3, so I can scan through these 3. And I'll share all the code with you, by the way, and I'll share all these PDFs with you too. So you have the source files. But the point is to train these on your own files. Here's the path to where my files sit. You can change this. You could change your question, right, based on your specific files, and do whatever you need to do. This is just a very basic example, but I wouldn't expect you to be looking at accuracy of risk reporting or banking risk metrics by any means. That might be what you're doing, but might have nothing whatsoever to do with what you need to do. You would just change the path to where all your files sit. That's right here, and change the question that you want to ask. And then the model will go ahead and search through all the text for all these files. You ask it the question, and it'll show you the relevancy of each question matching to each file and give you a quantitative score too. So you see 51.6% doesn't answer the question about accurate and reliable risk data to meet stress testing requirements. This says accuracy, integrity. A bank should be able to generate accurate and reliable risk data. And then it gets kind of cut off here. They did do the first 1,000 characters. I think some of it got used up over here. Okay, so this one is about 50% accurate. This is 42% accurate. Risk reporting would help banks identify potential risks even sooner, allowing for more timely, and then kind of gets cut off. So we have to tinker around with this, the number of characters that spits out. And then there was one more requirement that you can play around with. Maximum number of characters is 1,000. I think that's it. And then again, you would pick the model that you're working with. In this case, this is the model here. You go to the Hugging Face site that I just showed you. Over here, I picked a different model. Okay, this is the model I picked before. Oh, that's the transformer, I'm sorry. And the model is this model right here, right? So you pick the transformer, you pick the model, you dump in your specific PDFs or Word documents, whatever you have. You ask the relevant question, and you get these results, okay? This would be, that first one was the LLM. This is text retrieval plus LLM. I'm noticing a pattern here. It's taking a couple of minutes to generate the results. So I'm going to kick this one off just while I finish up the narrative here. Risk reporting would help banks identify potential crises sooner, allowing for more timely interaction or intervention, I guess. That's going, that direction. And then this is less relevant here. Only 24% match between, again, the body of the text and the question that you're asking based on this over here, cosine similarity, right? That's what that is for. So now we're only down to 24%. And we have weakness is how banks identify, measure, monitor, and control climate-related financial risks. Okay, so doesn't really answer the question. This is more relevant, and I think this really is the best answer based on that question that I asked. And it shows you the source data too. So that was the document BCBS 239. So now I'm asking the same question using a slightly different model. This is called Dense Retrieval. And in this case, we represent the documents as queries and embeddings and high dimensional space. So we have all of this potential for the models to interact with the documents, right? And how is the model going to learn what's in the document, the contents of the document, and be able to answer the question that you propose to the model? So that's the question. So how can the model do that? So we have to pick the transformer. Again, this is a transformer that we're using, and this is the question that we're asking. Should a bank be able to generate the accurate results? So the same thing. And again, it's looking at all the PDFs in this folder. So we've seen this technique used twice before, right? With a standard LLM, text retrieval LLM. This is dense retrieval. And let's see how accurate these scores are in terms of answering the question. So this is now 80% accurate, so much higher than what we saw before. A bank should be able to generate accurate and reliable risk data. Okay, so that pretty much answers the question. It gets cut off. Not sure why, because I set this to 1,000, but I have to tinker around with it or look at the documentation, because I thought the answer would be a little bit more robust. It's kind of truncated there, but that's okay. We have the risk score or the relevance score. We have the relevance score, and we have the document source and proof of why that's 80%, right? A bank should be able to generate accurate and reliable risk data. That comes from straight from the document, and that pretty much matches this, right? So that's why it's getting a high score. So that gives me a sense of assurance that this is working correctly. This is 62%. Risk reporting would help banks identify potential risks even sooner, allowing for more timely something. Got cut off there, so we don't know what. More timely response, maybe more timely reply to some type of banking crisis. Okay, so it's scanning through document number 3 now and matching, again, looking at cosine similarity, matching the text to the question. And let's see what it comes back with. And this is 59% accurate. And it says weakness in how banks identify, measure, and monitor and control climate-related financial risks. So that is kind of unrelated. I don't even know why it's coming back, but it has to do something, has to give you some kind of response based on that question you ask. Seems like it's a little bit high, but that's okay. The model is doing what it's supposed to do. This one, by far, is the most reliable and the most relevant, right? That's the relevant score. And I think it does answer that question. So if we have to, if your boss comes up to you with this question, or you just come up with this question yourself, this document right here is going to be the most relevant, right? By doing the model training testing and matching the question to the body of text in those 3 files. So that one is the most relevant. Let me kick off this next process right here. I think that is the 4th and the final, and it is. Yep. So in this last example, we are using embedding-based search, and this will allow you to perform semantic search by encoding both documents and queries. Again, this is the question that we're asking. Based on these 3 documents, which document has the most relevant information is going to be the most useful based on the question that I proposed to the model. And we split everything in the body of text into vectors. Remember, a vector is a direction, and I think it has magnitude. A vector has direction and magnitude. What was that? That was from my physics days and math too. I studied Calc 1 through 4. I forgot the definition of a vector. Let me see. What is a vector? In simple terms, yeah, simple. Keep it simple for me. In simple terms, a vector is quantity that has both magnitude, yep, that's what I thought, and size or length. So a vector in mathematics is magnitude of size and length. And this is how the model is able to interpret the body of text in each PDF, right? It has to vectorize that or convert the text into the length and the magnitude of that text, right? So a bigger vector is like a more, is a longer, basically it's a line, and it has magnitude, so it has strength, right? So in the last example here, this is an embedding-based search technique, And again, we're looking through those 3 documents. We're just printing the first. The second 2 aren't even relevant. This is the highest similarity score. The other 2 are going to be a little bit lower. And you can see, based on the question that we asked, we're asking the same question to these 4 models, right? And using the same transformer in each case and going to the same source data, right? They're contained on my desktop and these 3 PDFs. This one is the most similar, and we're looking at the first 1,000 characters, and it's printing out actually just the beginning of the PDF. It didn't actually print out the vector of words that matches this question. You know what? I think it's a mistake because I really wanted the vector of words. I ran this. It was late last night. I think it was like around midnight. I shut down, so I was pretty tired. I didn't realize that. I tested it, and the code ran, but it just produced the first 1,000 words, not the what makes this question relevant to that document. So let me go back and I will fix that. I think I know what to do. I think I can figure this out pretty quick. I will update that so it prints why the text, why this document is relevant, and the text that confirms that. Okay, so let me do a little digging into the documentation. I think that should be easy to fix that, and I'll get back to you guys. I'll make a tweak on that and make the update right here in the notes, and then I'll share all that with you when I post a video later today. And that's it. And I have a couple things in my notes: the standard large language model plus text retrieval plus dense retrieval and embedding-based search produce different results based on the similarity or relevance across different models and how these models perform. So again, you have to kind of test all these models, see which one is performing best, and then go with that one, because in advance, or a priori, it's called, before something happens, you can't know which model is going to perform the best. You have to test all 4, see what the output is, and then you can make a decision about which model is performing the best. You can't just say, well, this model usually works best, so I think I'm going to go with it. Based on the text that you feed into it, any one of these 4 models can outperform the others, right? You really have to run all 4 on those 3 files and see what the output is, and then pick that model that performs the best, okay? So I'll make the update over here, like I promised, and I will post my code so you can download this and copy and paste it and run it in your own environment. I'll post that when I post a video later today. Thanks for your time, everybody, and I'll see you in the next one. Bye.